Hi guys, welcome back. In today's video, we're going to look at using the formula sheet. Now there are some persons who don't pay attention to the formula sheet. There are some persons who deem it irrelevant, but whether or not you deem it irrelevant, it is a tool that you can use to help you. So for example, teaching over my past 10 years, I've realized that there are students who have used incorrect formulas that were provided on an examination. So to help students who avoid that error, I'm going to go through the formula sheet to help you to understand how we use it. And there are 3 questions that I'm going to work out using the formulas from the formula sheet. So let's get passing maths. So let's get to the point. Now the formula sheet can be divided into 3 main sections: measurement formulas, quadratic formulas, and trig formulas. So in our measurement formulas, we have the volume of a prism, the volume of a cylinder, the volume of a right pyramid, circumference, arc length, area of a circle, area of a sector, and area of a trapezium. Next, we have the roots of a quadratic equation if the equation takes the form of ax squared plus bx plus c equals 0, when x is equal to that formula minus b plus and minus the square root of b squared minus 4ac over 2a. And the trig formulas, where we have the trig ratio formulas, the area of a triangle, whether it's right angle triangle or non-right angle triangle, the sine rule, and we have the cosine rule. So sine rule, cosine rule, area of a triangle, the trig ratios. Now, guys, I'm begging you, don't have the formulas here and use an incorrect formula. Please, I'm begging you. If you're uncertain, or even when going through your exam paper after working out, check back the formula sheet to see that if you use any formula that was provided correctly in terms of using the correct formula for the correct components. Alright? So let's get to practicing. Let's practice our first question. Our first question is taken from January 2021, question number 6 and CSEC paper. The diagram below shows a rectangular tank with base 50 centimeter by 40 centimeter that is used to store water. So the tank is filled with water to a depth of 15 centimeter. Calculate the volume of water in the tank. So the question wants us to find the volume. Calculate the volume of water in the tank. The volume of water. Now let's pause and go to our formula sheet and see. Let us see how our formula sheet can help us. So looking on our formula sheet, we say volume of a prism, and it was a rectangular prism. So we say volume is equal to area of cross section times the height, which is the perpendicular length. So we're using this formula here. V equals AH, and A stands for the area of the cross section and H is the perpendicular length. So we have volume is equal to A times H. Now the area of our cross section, this is our cross section of the water in the tank. So if here is 40, here is 40, and if here is 15, then here is also 15. So the area of the cross section is going to be length times width. So volume is going to be 40 times 15, and the height is going to be 50. Now the depth and the height can be used interchangeably, right? However, this question can be worked both ways. So we have 40 times 15 times 50. So let's go ahead and calculate our 40 times 15 times 50. And that gives us 30,000. So we have 30,000. And what's our unit? Now, unit is important. So centimeter cube. And that's the volume. Or, without even the formula sheet, we know the regular volume. Length times width times height. So volume, so that would be 40 times 50 times 15. And we get our volume to be 30,000 centimeter cube. So either way, so if you had forgotten this formula, which I think is crazy to forget, but anyway, you can use the area of the cross section, which is the cross section of the water in the tank, times the height. And don't forget your units: volume, centimeter cube, meter cube, liter cube, whatever the unit may be. Now the same question continues to say that the cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank, which was the one that we were working out before. The container, which is completely filled with water, has a radius of 20 centimeter and a height of 21 centimeter. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So first thing we need to do, calculate the volume of the water in this tank. And they say that this tank is completely filled. So how do we find the volume of this shape? We want to know the volume of a cylinder. Now let's go back now to our formula sheet in case you have forgotten that. And next now we see the volume of a cylinder. V is equal to pi r square h, where r is the radius of the base and h is the perpendicular height. So V is equal to pi r square h. So V equals pi r square h. So we know that our radius is 20 centimeter. Our height is 21 centimeter. So we can go ahead and plug it in our formula. So V is equal to, if they don't tell you what to use as pi, you can go ahead and use your 3.142, 3.14, or your 22/7, doesn't matter. Times radius, which is 20 square, and times the perpendicular height, which is 21 centimeter. Don't forget a unit like what I'm doing. So write on your little centimeter. So we know that multiplying out, so our calculators, let me clear off. So we have our fraction button, 22/7 times open bracket 20 close bracket square times 21, and that's going to give me 26,400 centimeter cube. So the volume of the water in this tank is 26,400 centimeter cube. So this tank has 26,400 centimeter cube of water. Now the question asks now, what was the amount of water, what is the total volume of water that is now in the rectangular tank? So this is the volume in this tank. So the total volume is equal to the water in the rectangular tank plus the water in the cylindrical container. So the volume of rectangular tank plus the volume of the cylindrical container, you can say the cylindrical tank. Alright, so this volume of the cylindrical tank is 26,400 centimeter cube, and the volume of the tank, the water in the tank before, let's check. Right, so the volume before was 30,000, so let's add that now. So 30,000 plus 26,400, so therefore the total volume is equal to 56,400 centimeter cube. So you see where we use our formula V equal pi r square and focus on the keyword, calculate the total volume of water that is now in the rectangular tank. Now for the next part, now part C says that we're supposed to show that the new depth of the water in the rectangular tank is 28.2 centimeters. So let's do a quick flashback. Now they told us that the amount of, we were to find the amount of water that was in this, because they use this tank to help fill it up quickly. So they add the water from this tank, from this cylindrical tank, into this rectangular tank. Now before, the depth of the water was 15 centimeters, and by adding the water from this tank, the depth is now 28.2. Now they're asking you now to prove or to show that the new depth is actually 28.2. Now let's work with what we know. What do we know? The volume of the water in the tank is now 56,400. That's what we know. And we know that the cross section of the tank, you can say either 40 by 50 or whatever. We know that it's a 40 by 50 by the new height, which is now 28.2, but we have to prove it. So hence, we know the formula: volume equal area of cross section times height. We know the volume, don't? Because the volume of the water. Alright, now for part C. Part C says show that the new depth of water in the rectangular tank is 28.2 centimeters. Now, what are they talking about? Remember, first they gave you a rectangular tank. They gave you a rectangular tank first, where the water depth was 15 centimeters. Then, in the next part of the question, they explain that they use this particular tank to fetch water to fill this particular rectangular tank. So hence, what they now want to find is what is the new height or the new depth of the water after they have added this amount of water into this rectangular tank. So now let's write down what we know. What do we know? We know that the volume of the water in the rectangular tank is what? 56,400. So we know that the volume of water in the rectangular tank is 56,400 centimeter cube. What else we know? We know that H normally represents the height or the depth or whatever the water. So we know that H, can say let H, wow, my H beautiful, what is H? Let H represent the new depth of water. And then we can apply our formula. What's the formula that we're going to be using? We know we have the area of the cross section times height. So volume is equal to area of the cross section times height. So we go back now to calculate the area for our cross section. Now let's look back at our cross section to see what it's like again. So we have 40 times 15. However, our 15 is now going to be h times our height of 50. So we have 40 times h times 50. So the same thing as saying 40 times 50. Oh, and we know our volume, so we can substitute our value of V. So volume is 56,400 is equal to 40 times 50 times h. Just to separate it a bit for easy calculation. Yes, laugh at me stuttering. So now we know we have 56,400 is equal to 5 fourths 20, so we have 2,000 centimeter cube. I keep leaving off my unit, centimeter cube, times height, which is the depth of our tank, or we could use D if you wanted to use D. And we're going to solve for h or transpose for h. So we're going to divide both sides by 2,000 centimeter cube. So let's pull up our calculator. So we have 56,400 divided by 2,000, and we get 141 over 5, 28.2. Oh, and this 2,000 here would be square. Sorry about the cube. It's going to be square, and then we have this into this, so we're left with only centimeter. So we get 2.8 centimeter. Gives us the depth of the water in the tank currently. Alright, and the final part for this question says the vertical height of the rectangular tank is 48 centimeter. So determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. Now it says how many more cylindrical container, and it's telling us straight out that the vertical height of the rectangular tank is 48 centimeters. So it's just saying this distance here, not the water now, the entire distance here is 48. That's what it's telling you now, that this entire distance here is 48. All I hear, so 48. Hence, they're asking now how many more of the cylindrical tank, how many more containers of this water, how much time have you got to fill up back this to completely full the rectangular tank. So let's write down what we have and what we already know already. So we know the volume, or we can find the volume of the rectangular tank. So the entire, what's the total capacity of water that it can hold. So the volume of the rectangular tank, and it should be rectangular. Yes, so I'm spell bad too. Alright, rectangular tank. So we know area cross section times height, same thing as length times width times height. So we have a 40 centimeter times with 50 centimeter times with 48 centimeter, and that gives me, alright, let's do it quick on the calculator without me having to try. So 40 times 50 times 48, and that gives me 96,000. So we have 96,000 centimeter cube. We already know that the volume of the water in the tank, total volume of water in the tank is 56,400 centimeter cube. And we know this from previous parts, from right here. What else do we need to know? So therefore, the rectangular tank can hold this. That's the maximum it can hold, 96,000. That's what it needs to be filled completely. I would know that the total volume of water in the tank already is 56,400. What else we already know? We know that the volume of water that the cylindrical tank can hold is what again? Let's check back. Is 26,400. We know that can hold that maximum. So 26,400 now centimeter cube. Now we need to know how much more water is needed. I'm going to pull up a little bit, show the next question, but that's okay. How much more water is needed to fill the tank? So the tank have this in it already, and it can hold this maximum. So it needs more. So it needs now to fill the rectangular tank completely. It needs, so going to be 96,000 minus 56,400. So it needs that more to be filled. So 96,000 minus 56,400. So it needs 39,600 more centimeter cube. I'm running out of space. So it needs 39,600 centimeter cube more. Remember now, the question said that it uses this container to fill this container. And we know that this container holds 26,400. Now, we want to know, running out of space, but I'm going to change the color. Alright, I'm going to write it right here and then erase it for the next question. So, to find out the number of cylindrical containers of water needed to fill the tank completely, we're going to have just a shortcut number of cylinder container, and it's more because the keyword is how many more. Just shorten everything here. It needs 39,600 more of this to full, and one tank holds 26,000. Sorry, one tank holds 26,400. So it's going to be 39,600 divided by 26,400. And let's on our calculator quickly. So we have, let's clear. Oh, I didn't have to clear. Answer divided by 26400. And we get 2 over 3, same thing as 1.5. And this is equal to 1.5 containers more. I should have organized my space better, but the point is, we know the volume of the rectangular tank, the complete volume that it can hold, the total capacity of the water that can be held in the tank is 96,000, right? The total volume of water that is already in the tank is 56,400. So how much more it needs to be filled is 39,600. Remember, we use the cylindrical tank to fill the rectangular tank, and the cylindrical tank can hold a maximum capacity of water of 26,400. So we want to know how many more 26,400 or how many more that tank is of that tank of water is needed, the cylindrical tank I'm speaking, is needed to fill the rectangular tank. Alright, next question we're looking at is a question that says 2x squared plus 5x minus 3 is equal to 0. So it's basically asking you guys to solve it. Now, for some students, they can easily factorize, but for some students, they struggle with finding the factors. Yes, as easy as the question may seem, there are students who struggle to find the factors. And sometime under exam pressure, you get nervous and things that you know how to do, you forget. So if you have forgotten how to find the factors, no need to fear. The quadratic formula is here. Let's look back at the quadratic formula. Yes, laugh at Mr. Turn again. Now we have, once the equation is in the form of ax squared plus bx plus c equal to 0, then we can find the value of x using x is equal to minus b plus and minus the square root of b squared minus 4ac all over 2a. We're going to apply this formula now to solve the quadratic equation below. Alright, so the formula that we're using, x is equal to minus b plus and minus the square root of b squared minus 4ac all over 2 times a. And I have videos on this topic already, so you can click the link above if you want to watch videos on this topic. Alright, so first we need to identify what is our a, b, and c. So we have our 2x squared plus 5x minus 3 is equal to 0. So we can say by comparison, when comparing it to ax squared plus bx plus c equals to 0. So by comparison, a is equal to 2, b is equal to 5, and c is equal to negative 3. So we can go ahead and plug these into our formula. So x is equal to minus 5 plus and minus b, which is 5 squared minus 4 times a, which is 2 times c, which is negative 3 all over 2 times 2. So let's clear up now. X is equal to minus 5 plus and minus. So 5 squared is 25, and we have negative 8 times negative 3, so we get positive 24 all over 4. 2 times 2, 4. Now we can simplify further. We know that x is equal to minus 5 plus and minus the square root of 25 plus 24 gives me 49 all over 4. So x is equal to minus 5. I would know that the square root of 49 is 7. Sorry. Square root of 49 is 7. 7/4. So therefore x is equal to minus 5 plus 7/4 and or minus 5 minus 7/4. So we know that x is equal to 7 minus 5, that's 2/4, which works out to 1/2. And we have minus 5 and minus 7 gives us negative 12/4. So we get negative 3. So the values of x will be 1/2 and negative 3. And this is also using the formula that is already on your formula sheet if you are unable to figure out the factors easily and factorize. And sometimes, as we said, we get stressed during exams, so it happens. And for our final question, the diagram below shows a quadrilateral PQRS where PQ and SR are parallel lines. I like to put on some indicators, parallel lines. That helps me to recall while I'm dealing with the diagram. Then we have SQ. So SQ right here is 8 centimeter. The angle SPQ is 90 degrees. The angle SQR is 82 degrees, and the angle QSR is 30 degrees. Determine the length PS. So want to find the length PS right here. Now we only have the hypotenuse, because we said it's a right angle triangle, and it's asking us to find the length PS, and we need some angles. So let's observe our diagram. See, so we have one triangle here, right angle triangle, and then we have another triangle here, a non-right angle triangle. Okay, let's look at it. It's a parallel line and it's our transversal lines. So therefore we have what we call alternate angles, or in some cases for students to remember easier, we say z angles. So this angle is equal to this angle once these two lines are parallel. So we have our, so if here is 30 degrees, then this angle here is 30 degrees, because they call alternate angles. Alright, so we have our angle here now. So we have the opposite side and our hypotenuse. So we have our opposite and the hypotenuse. Now you don't need the formula sheet to remember this, but let's look at the formula sheet. So what trig ratio matches the opposite side and the hypotenuse side? So we're going to use sine the angle. Now you should know this, but in case there are students who do forget, so if you do forget, please consult your formula sheet. So using sine angle is equal to opposite over the hypotenuse. So sine 30, and our opposite side is what we want to find, which is PS over the hypotenuse, which is 8. So to find PS is going to be 8 sine 30 is equal to PS. And I already have a video working on questions using the trig ratios, so see the link above. Then our calculators now, give us some space. So we have 8 sine 30, and that gives me 4. Good. So 4 centimeter is PS. So therefore, the length PS is equal to 4 centimeters. So that's it. So your alternate angles, or we call them Z angles for layman terms. So your alternate angles, and then you apply your trig ratios because it's a right angle triangle. The triangle PQS is a right angle triangle. Now the next part says to calculate the length of PQ. Calculate the length of PQ. So let's look back at our diagram. So we have PQ. So calculate the length right here. Now we could use two trig ratios here, you know, because you could call PQ. So we'll have our angle. So we'll have, this will be our adjacent side, and our hypotenuse, which is 8. So we know that's cos. So we have cos the angle, which is equal to the adjacent over the hypotenuse, which is also on your formula sheet, just in case you forget. So cos the angle, and our angle is 30, is equal to, what's the adjacent side? Let's look back. With the adjacent side is just PQ, that's what we want to find. PQ, and our hypotenuse is 8 centimeters. So to find the side PQ is going to be 8 cos 30 is equal to PQ. So our calculadora, our calculators, or just my term, so 8 cos 30 is equal to 4 root 3. So 4 root 3 is equal to PQ. And for some students, I know that their calculators may not show them like mine. So you could say, press the SD to get 6.93 to 2 decimal place. And DP stands for decimal place, just shorthand for now. Alright, so that's it. Or, what other way could we have worked it out? We already did calculate that the length of PS is 4 done. So we know, so here's now 4 centimeter. So we could have used this as our adjacent side, and our opposite side we could use tan. So let's see what we get. So tan, the angle is equal to the opposite over the adjacent. So it's tan 30 is equal to, what's the opposite side? 4. And the adjacent is what we want to find. So 4 over PQ. So to find our PQ, it's going to be solving for PQ, same thing as transposing for PQ. We're going to have PQ tan 30 is equal to 4, and divide both sides by tan 30. So PQ is equal to 4 divided by tan 30. Let's see what we get. Voila! What do you know? 4 root 3. 4 root 3 is the same as 6.93 to 2 decimal places. Now to complete this question, the final part is asking us to find the area of PQRS. So the entire area of this quadrilateral here. Now to find the area of PQRS, we must first observe that PQRS takes the shape of a trapezium. So we're going to use the area of a trapezium. So we have area, so let's write that down because it takes the form. So it's the area of a trapezium. And let's check our formula sheet to see if it tells us what's the area of a trapezium in case you don't know or don't recall. And the area of a trapezium according to our formula sheet is A equal half A plus B times H, where A and B are the length of parallel sides and H is the perpendicular distance between the parallel sides. So half A is equal to half A plus B times H. Now let's look if we have all the components for this formula. So we have our perpendicular height, which is 4, and it is 4 because these two sides here are parallel. That means this angle here and this angle here, what we call co-interior angles, and co-interior angles add to give 180. So if here is 90, then automatically here must also be 90. So we know that the perpendicular height is going to be 4. So we know that our H is equal to 4. So we can say that our H is equal to 4. Now our A and B, now let's check for those. So our A and B are the opposite, the parallel lines that are opposite to each other. Now we had find PQ done, and PQ up here is what? 4 root 3. So we can tell that our A is 4 root 3, but our B now, do we know our B? No, we don't know our B as yet. So let's look back. So here would be the B, here would be the A, and the entire thing here, so the perpendicular height H, opposite sides that are parallel to each other, A and B. Now we don't know our B, but let us look at the length SR in terms of the non-right angle triangle here. Let us look at QSR. Now automatically what stands out right there, we're able to use the sine rule, don't? Because once we have two angles and one side opposite to one of the angles, then we're able to use the sine rule. Now the two angles would be, so we know angles in a triangle add to give 180, so it's 82 plus 30, and that gives us 112, and then 180 minus 112, that gives us 68 degrees. So this angle here is 68 degrees. So we have two angles and a side opposite to one of the angles. So we have a side opposite to an angle, and then we have the side 82 opposite to the side B that we want to find. So let's apply the sine rule. So using the sine rule, so we have alright, so let's match. So we have 68. So we have 8 centimeter to 68. So we have 8 centimeters over 68, sorry, sine 68, which is equal to B over sine 82. So b over sine 82. And we can go ahead and transpose for b. So let's cross multiply and transpose for b. So we have 8 sine 82 is equal to b sine 68. And we solve for b by dividing both sides by 68. So let's go ahead and work on our calculators. So we have 8 sine 82 over sine 68, and that gives us 8.5. Hold on, I'm brain forget a number which is not normal. 8.44443. Let's use as much of the digits that we can use, and this would be centimeter. Is it centimeter? Did I give us an yeah, centimeter? Good. Now let's plug it in to find the area of the trapezium. Sorry for my mess. I hope you're following though. So A is equal to half A, which is your 4√3, plus 8.5443. Hold on, let me just gather some space a bit, because I write very big. So let me take my time and write a bit smaller. So A is equal to half times 4√3, which is the 6.93, plus 8.544, 8.54 times the height, or perpendicular height, which is 4. So A is equal, we know that we can, it's multiplication, so we can find half of the 4 here, which is 2, and then we can use our calculator to finish the rest, or we could use our calculator to do the entire thing. So clear. So we have half, bracket 6.93 plus 8.54, sorry, close bracket, times 4. What did I do wrong? What did I put in wrong? Put in something wrong? 1/2 6.93 plus 8.54, close bracket, 4 times 4. Okay, this calculator uses multiplication sign, not necessarily needed, however. So we get 30.94. So funny, because on the other case you don't have to do that. Alright, so we have 30.94, and because it's area, centimeter square, and this would be automatically to 2 decimal places. Alright guys, so these are some questions that you can practice. I guess this video was a bit lengthy, but that's okay. Good practice, measurement, trigonometry, and quadratics.